Okay, Wildcats. Today we're looking at Journal page 57, Graphing Rational Functions. Graphing rational function steps. Step 1, factor the expression. Step 2, identify the holes. Step 3, find the vertical asymptotes by setting the denominator equal to 0 and solving for x. Step 4, find the horizontal asymptotes or the slant asymptote by using long division. Step 5, find the x-intercepts zeros by setting the denominator equal to 0 and solving for x. Step 6, graph the above information. Step 7, graph the critical points. Okay, if you would, update your notes. Now your notes are updated, let's take a look at the examples. All right. Find the zeros, vertical asymptote, horizontal asymptote, and holes. Then graph the rational function. All right, so the first step is we need to factor the numerator. Okay, so we know two parentheses. X is in the denominator, and there's nothing you can do to factor it, so we'd leave that be. We know that x and x make x squared. So now we need to find all the combinations that make -6 combined to be +1. Okay, so let's take a look. We know that 1 times -6 is -6, 2 times -3 is -6, 3 times -2 is -6, 6 minus 1 is -6. Now, 1 minus 6 combines to be -5, 2 minus 3 combines to be -1, 3 minus 2 combines to be 1, which is the middle term, 1x. So these are our factors, x plus 3, x minus 2. Okay, now nothing divides and becomes 1, so there's no holes. Okay, now for the zeros, we set the numerator equal to 0. So x plus 3 equal to 0, and x minus 2 equal to 0. So we solve for x, so x equals -3. So we have a 0 at -3, 0. Oh, almost put that on the wrong graph. Whoa. -3, 0. Okay, so we solve for x, x equals 2. So we have a 0 at 2, 0. Okay. Now, for the vertical asymptote, we set the denominator equal to 0, so x equals 0. And let's graph the vertical asymptote in yellow. Okay. Okay. Now let's find the horizontal slant asymptote. And we use that using long division. So 1x divided into 1x squared plus 1x minus 6. Well, now you ask yourself, what do you multiply x by to give you 1x squared? The answer to that is 1x. Now we multiply 1x times 1x is 1x squared. Subtract. Bring down the 1x. Now you ask yourself, what do you multiply 1x by to give you 1x? The answer to that is plus 1. Since you have an x in the quotient, you know it's a slant asymptote. So your slant asymptote is y equals 1x divided by 1 plus 1. Okay, so let's graph that. So we start at 0, 1, and we go up 1 to the right 1, 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 and so on. Now we know we can also go down 1 to the left 1, down 1 to the left 1, and so on. Okay. Now for our critical points, we can use our intercepts because that tells us where the curves are. So -3, 0, and 2, 0 are critical points. Because they tell us, since this point's here, we know the curve is right here. And since this point's right here, we know the curve is here. Okay, so go ahead and finish up example 1. All right, let's take a look at example 2. Now, the first thing we're going to do is factor the numerator and denominator. So here we can divide 2 by both terms. So we're left with 2 times x squared minus 1. And for the time being, let's just leave that as x squared minus 4. Okay. Now, we know that x squared minus 1 is the difference of squares. So we have 2 times x minus 1 times x plus 1. And we know that x squared minus 4 is a difference of squares, which is x minus 2x plus 2. Now, we see here that nothing divides and becomes 1, so there's no wholes. Okay. Now, we set the numerator equal to 0 and solve for x. So that's 2 times x minus 1 equal to 0. Now here we divide both sides by 2. That leaves x minus 1 equal to 0. And then you just add 1 to both sides, so x equals 1. So we have a 0 at 1, 0. Okay. Now we set x plus 1 equal to 0. Well, subtract 1 from both sides. X equals -1. So you have 0 at -1, 0. Okay. Now for the vertical asymptote, we set x minus 2 equal to 0 and x plus 2 equal to 0. So we add 2 to both sides. X equals 2 is one of your vertical asymptotes, and x equals -2 is your other vertical asymptote. Okay, so x equals 2. And x equals -2. Okay. Now, you have a horizontal and slant asymptote. Or I should say horizontal or slant asymptote. So we use long division. Okay. So we have x squared. Okay, makes really space for the critical points. X squared plus 0x minus 4 divided into 2x squared plus 0x minus 2. Now you ask yourself, what do you multiply x squared by to give you 2x squared? The answer to that is 2. That completes your quotient. So we know it's a horizontal asymptote since there's no x in the quotient. So y equals 2 is your horizontal asymptote. So let's graph that. Y equals 2. All right, critical points. We need to know if our curve is above the horizontal or below. So to do that, we need to test a point. Let's test x equals -3 because that point is to the left of this vertical asymptote. Okay, so what we have to do is plug -3 into the function, okay, to find the y value. So f of -3 equals 2 times -3 squared minus 2 divided by -3 squared minus 4. Now, in this case, you're going to want to use your calculator. So, all right. So we're going to do control divide 2 parentheses negative 3 squared minus 2 divided by parentheses negative 3. Whenever you square a negative number, it has to be in parentheses. Negative 3 squared minus 4. You get a fraction. We don't want that fraction. We want a decimal. Control enter 3.2. Now, this is a good opportunity. I teach Math UIL, and sometimes my students have to set their calculator up for competition, and that's why that's easier. If that ever happens, go to On, Settings, Document Settings. You're going to want to go to Restore Settings, press OK, and then you have to go back, and you want to make sure you say that Make Default, press OK. Now, when we go to Calculate, and I type this in, and press Control Enter, ta-da, the E is gone. Okay? All right. Nonetheless, that tells us that our point is negative 3, 2. So negative 3, 3.2, which is about here. Okay? Now that's critical because it tells us that our curve is here. Now, these points tell us what happens here because we know it's going to have to go here, go up, and then go back down to here. Okay? Now we need to find out what happens here. So we're going to need to add another line here. And let's evaluate a point. I would say evaluate 3 to find out, again, the points above or below the horizontal asymptote. So f of 3 equals 2 times 3 squared minus 2 divided by 3 squared minus 4. Now, in essence, when you square a negative 3 and a positive 3, it's the same. So in essence, these are the same, so you're going to get 3.2. So our point is 3.2, which is critical because it tells us our point is here. Okay, so go ahead and finish up example 2. All right, now let's take a look at example 3. Okay, so the first thing we need to do is factor the numerator and denominator, but there's nothing to factor because x squared is just going to be x and x. That doesn't help us, okay? Now we notice that nothing divides and becomes a 1, so there's no wholes. Okay. Now for the zeros, we set the numerator equal to 0, so x minus 1 equal to 0. So x equals 1. So we have a 0 at 1, comma 0. Okay. Now for the vertical asymptote, we set the denominator equal to 0, so you get x squared equal to 0. Take the square root of both sides, x equals 0. So you have a vertical asymptote at x equals 0. Okay. Now, for the horizontal slant asymptote, we divide, so that's 1x squared plus 0x divided into, now there's no x squared, so that's 0x squared plus 1x minus 1. Okay. Now you ask yourself, what do you multiply x squared to give you 0 squared? The answer to that is 0. There's no x in the question. Question is completed. So we know it's a horizontal asymptote at y equals 0. Okay. Now, this is a unique situation in that there's actually a point on the asymptote. That can occur. It happens rarely, but it can. Okay? All right. So for our critical points, we need a point to the left of the horizontal asymptote. So let's use x equals -1. Okay? So f of -1 equals -1 minus 1 divided by -1 squared. We can do this without a calculator, which we know -1 minus 1 is -2, and -1 squared is +1, so that's just -2 divided by 1, which is just -2. Okay, so we have a point, -1, -2. That's critical because that tells us our curve is right here. Now, the next thing we need to do is pick a point to find out if this curve is going up or if it's going down. Okay, so let's use a point when x is 2. So f of 2, okay, equals 2 minus 1 divided by 2 squared. Well, that's 1 divided by 4. So at 2, our point is 1/4, which is right there. Now, that's critical because it tells us our curve is actually going to go above the asymptotes like that. Yeah, that's very special, and that rarely happens where the curve can actually cross the asymptote, but in this case it does. Okay. All right, so if you would, go ahead and finish up example 3. All right, now let's take a look at example 4. Okay, so the first thing we do is factor the numerator and denominator. Okay, now we know 2 parentheses. We know x and x. And then we need to find out what combination will multiply to be +2 and combine to be -3. Okay? All right. So we know that -1 times -2 is +2. And that's the only combination that will multiply to be a +2. So let's see if it combines to be -3. Well, -1 minus 2 is -3. So that works. So our factors are x minus 1 and x minus 2. Okay? All right. Now, we see here that we can factor out an x from both of these terms. So it leaves us x times x minus 1. Now, you'll see here that this divides and becomes 1, so we have a whole. So we set x minus 1 equal to 0, so x equals 1. Now, a whole is a point, so we need to evaluate the function at 1. Ignoring this as divides becomes a 1. So f of 1 equals 1 minus 2 divided by 1, which equals -1. So we have a whole at 1 comma -1. So we go to 1, -1, and we have a whole. That's an open circle at 1, -1. Okay? Now for the zeros, we set the numerator equals 0, which we only set the x minus 2. So x minus 2 equal to 0. So x equals 2. So we have a 0 at 2 comma 0. Okay? Now vertical asymptote, we set the denominator equal to 0. So that's x equals 0. Okay. Now for the horizontal slant asymptote, we divide. So then that's x squared plus, oh, whoa, what am I doing? Not plus, squared minus x, and put 1 there, divided into 1x squared minus 3x plus 2. Now you ask yourself, what do you multiply x squared to give you x squared? The answer to that is 1. There's no x, so it's a horizontal asymptote at y equals 1. Okay? Now, we need a critical point to the left of 0, okay? And let's use next is negative 2. That works. Okay, because that's to the left of x equals 0. So now we evaluate the function f of negative 2, and we ignore, remember, we ignore the whole. So then that's negative 2 minus 2 divided by negative 2, which equals a negative 4 divided by a negative 2, which equals positive 2. So our critical point is negative 2, 2. So negative 2, 2 tells us that our curve is above the asymptote. And then we can use these as critical points because it tells us our curve is here. Okay, so go ahead and finish up example 4 and start working on your assignment, and have a wonderful Wildcat day.